Hi there, this is Math 6, Unit 5, Lesson 4, adding and subtracting decimals with many non-zero digits. Okay, so we're going to be doing some practicing of adding and subtracting decimals today, so here we go. First off, we have the cost of a photo print. So here are three ways to write a subtraction calculation. What do you notice, and what do you wonder? So take a look at these three things here, and what is it that you're noticing or wondering about the way those three subtraction calculations are set up? If you want to pause and take a moment to talk about it as a class, that's okay. Just press pause in the video and then come on back together. Alrighty. Question 2. It says, Claire bought a photo for 17 cents. Let me back up real quick. So what I'm noticing and wondering here is I'm noticing that we're subtracting 0.17 each time. But what I'm noticing here is that the 5 is moving places with each one of the equations, right? It's either over the 0, the 1, or the 7, which means it's a question about place value. It's a question about where does this 5 actually belong, because wherever I put it is going to determine the solution I could actually come up with, right? It doesn't have a decimal point anywhere, so I don't know where it's supposed to belong, so it's not very clear. But let's just see what's next. Claire bought a photo for 17 cents and paid with a $5 bill. Okay, look at the previous question. Which way of writing the numbers could Claire use to find the change she should receive? So change is kind of what's left after you take something away, right? That's our change. Be prepared to explain how you know. So we have a $5 bill and we have 17 cents. Now 17 cents would be written in terms of money, we would write it as 17 cents. So that's the 17 cents part there. So the question is, where does the $5 go? Okay, well 17 cents is there. Would this be $5? Would that be $5? Or would that be $5? From my understanding, I would say $5 looks like this. 5.00, and I would use the first one as my equation that I would use to find out how much change she would have left, because that shows $5 there. So let's find the amount of change that she would receive and show your reasoning. Okay, so if we do that there, we would do $5 minus the 17 cents. Okay, now I notice I can't do 0 minus 7 or 0 minus 1, so I'm going to have to unbundle this 5 and make it a 4, and then make that a 10. Okay, so we unbundle and regroup it over there. Now the 10, I'm going to unbundle that and make it a 9 in one of those. So 10 minus 7 is 3, 9 minus 1 is 8. I need to keep my decimal place always lined up there, and 4 minus 0 is 4. So the change that she would receive would be $4.83. Sorry, I chopped off a little bit there. Let's move down to number 2, activity 2, decimals all around. Find the value of each expression and show your reasoning. Okay, so for the first one, we have 11.3. So I'm going to rewrite that real quick as 11.3, and we're subtracting 9.5. It's important that our decimals line up, so I'm going to put the 9 below the second one and line my decimal up like so. Okay, so that everything lines up well. 3 minus 5, I can't do that, so I'm going to have to unbundle the 1 right there. I know it looks like an 11, but we're going to unbundle that 1, make it a 0, and put it over there. Okay, so 13 minus 5 is 8. Keep my decimal place. Now, technically, I'd be looking and saying 0 minus 9 I can't do, so I'd have to borrow from this one and then put it over there, right? That's technically what I'm going to do. So 10 minus 9, which is 1. So you put 1.8. For the next one, we have 318.8. And we're going to subtract 94.63. Again, look at where your decimal's at and figure out how you want to write that. I have two values to the left of the decimal, so I'm going to write the 9 below the 1, the 4 below the 8, and do 0.63. Now in this case, notice here that I don't have anything right above the 3. That doesn't mean there's nothing there, because there's always something there. In fact, there's always at least a 0 there, and I could have more zeros to the right, as many as we wanted to put there. So I'm going to use that 0 to hold the space so that I can complete the equation. That's a key piece there, is adding that 0 to the equation. Now, I cannot do 0 minus 3, so I'm going to borrow from here. The way I used to teach it back when I used to do second grade is I say we're going to suck one out of here, We're going to make it smaller, and we're going to spit it out there. We used to call it suck, small, spit. Silly, I know, but that was second grade. So 10 minus 3 is 7. 7 minus 6 is 1. Keep our decimal place. 8 minus 4, I can do that, that's 4. 1 minus 9, can't do, so I'm going to make it smaller. I'm going to unbundle that there and put it over here. So 11 minus 9 is 2, and then 2 minus nothing, or 2 minus 0 technically, is 2. So we have 224.17. And our last one, 0.02, and we're going to subtract from it 0.0116. So again, notice that I need to add some non-zero digits, I guess would be, right here to hold those places in those place values in place there, so that I can do some subtraction. I can't do 0 minus 6. I can't borrow from that, so I have to borrow from here. So this becomes a 1, and that becomes a 10. Got to keep going though. The 10 I borrow from, make it a 9, and I make this a 10. The 10 minus 6 is 4. 9 minus 1 is 8. 1 minus 1 is 0. 0 minus 0 is 0. Keep my decimal point, and 0 minus 0 is 0. Alright, so now with a partner, what we want you to do is to discuss with a partner which method or methods did you use in the previous question and why. In what ways were your methods effective? Was there an expression for which your methods did not work as well as expected? So how did you solve those there? And what was working for you is what you want to talk about with your neighbor real quick. Okay, turn the page. Alright, number 3. Lynn's grandmother ordered needles that were 0.3125 inches long to administer her medication, but the pharmacist sent her needles that were 0.6875 inches long. How much longer were these needles than the ones she ordered? Show your reasoning. So a couple things here. We have a couple numbers here and here. It asks how much longer. How much longer is a question about finding the difference. And so we're going to compare two numbers here. And when we compare numbers like this, we're going to put the larger one on top of the greater number, so 0.6875, and we'll subtract the smaller number, 3125. In this case here, I have the same number of digits in the equation in each number, so I don't have to worry about where they are adding in the extra zeros, but I do want to make sure everything lines up based upon the decimal, so we're good there. Right, I can even put my decimal down early if I wanted to. So 5 minus 5 is 0, 7 minus 2 is 5, 8 minus 1 is 7, 6 minus 3 is 3, and 0 minus 0 is 0. And so the difference is going to be 0.375 and 0. Alright, that's the idea. Number 4. There is 0.162 or 162 thousandths liters of water in a 1 liter bottle. Notice this is not a liter, this is a liter, this is 162 thousandths of a liter. How much more water should be put in the bottle so it contains exactly 1 liter? So how much more, again, is we're asking about. Think of it this way. Here is a bottle of water. Well, it's a terrible bottle of water. And we have this much in it. Okay. We know it can hold 1 whole liter. And so far it has 0.162. We want to know how much is going to fit into that space there. So essentially, we are doing 1 minus 0.162. So it's a little bit like our first question we started with, the notice and wonder. The 1 goes here because that's where 1 liter is at. But I need to include then what? I need to include 3 zeros there to hold those spaces. So now I'm going to borrow and move it there. I'm going to borrow, move it there, or unbundle. Unbundle the 10, make it 9 and 1 of 10 of those. And now we can start to subtract. 10 minus 2 is 8, 9 minus 6 is 3, 9 minus 1 is 8, keep my decimal place, and 0 minus 0 is still 0. So how many more liters of water would she need? She needs 8.838, or 838 thousandths liters of water. Number 5. 1 micrometer is 1/1,000,000th of a meter. Wow, so a micrometer is 1/1,000,000th of a meter. So 1,000,000th place. Let's think about this here. That's going to be, we have tens, hundreds, thousands, 10,000, 100,000, millionth. So that's what a millionth is in decimal places, right? They have 1, 2, 3, 4, 5 zeros right there holding that in space. And so it's in the 6th spot is where the millionth is going to be. A red blood cell contains 7.5 micrometers. Okay, so 7.5 micrometers would be written as, in this case here, that's going to be 0.0234 and because it's 7.5, that means I have 7 of them and half of another, so I'll write it like that. Okay, so I have the 5 zeros and there's my 7.5. A coarse grain of sand is about 70 micrometers. Well, 70 is going to be written a little differently, okay? And that's because, which is how it is, we're going to write 0, I'm going to write 1, 2, 3, and 4. I'm only going to have 4 zeros this time, and that's because I need to put 70 right there. Right? That's my 70, as I read it, into the micrometer spot there. So it might be a little tricky to kind of figure out what does that look like, how do you write that out, but that's the way that's done. Okay, so that's 70 micrometers because it's 70 millionth. That's how you would read that here. Whereas this is actually 7.5 millionth because we're reading it from that space there. Now to find the difference is subtracting. We'll take the larger one, which is 0.123470. We'll subtract 0.123457.5. Means I need to add one more 0 there in order to do this smoothly. I'm going to borrow from the 7, make that a 10, borrow from the 10, make it a 9. Now we'll do 10 minus 5 is 5, 9 minus 7 is 2, 6 minus 0 is 0, and then we have 1, 2, 3, 4 zeros there, decimal, and 0. So you should have 4 zeros here, and then 625. Okay, so if you want to read this out then, if this is our, this is our micrometer, which is the millionth spot there, we would say in this case here we have 62.5 micrometers. That is the difference between the two, it's 62.5 micrometers. Which, if you think of it a different way, we have 70 and 7.5. So we have 70 micrometers minus 7.5 micrometers, like this. And we borrow 10, borrow, and we have 5, we have 2, we have 6, we have 62.5 micrometers that way. Now you have to go back and say, well, how do you write 62.5? Well, again, it's right here, just like that. So these are the same. So you might have gone that way to get to 62.5, but if you want to write that as that proper decimal, it looks like that. So there you go. 2 ways of looking at that same problem. Alright, activity 3, missing numbers. For this next activity, it says write the missing digits in each calculation so that the value of each sum or difference is correct. Be prepared to explain your reasoning. Okay, so when you look at this here, just know that we're only going to be putting in numbers for where the boxes are going to be. Okay, this answer, for example, is actually going to be 1. And we could write it out as 1.000 if you wanted to, but the answer is going to be 1. So we have to think about 4 plus what number can get you a 0. Okay, we're obviously going to be getting something we're going to carry. We're going to carry it over. So I think about 4 plus 6 is 10. So that becomes 1, 0, 10, like that. So I have 1. 1 plus 0 plus what can give me 10? I need 9 more, because 1 plus 9 is 10. And then here, I want to get another 10, so 1 plus 4 is 5, plus 5 more is 10. And now 1 plus nothing is 1. So I'm going to put a 0 there and keep the decimal point. So we would say 0.596. Okay? This is the same idea right here. we're going to have a decimal point and a decimal point, and I know this is going to, these will be zeros down here because I don't want to have any other value, otherwise the answer is not 10. So again, I think about 5 plus what number can give me 10? 5 plus 5 is 10. And then 1 plus 6 is 7. 7 plus 3 is 10. And 1 plus 7 is 8. 8 plus 2 is 10. And 8 plus 1 is 9. 9 plus 1 is 10. And 1 plus 9 is 10. So we just leave a 0 right there. Alright, that's some addition ones there. Let's look at the subtraction. We have 0.7 and nothing right there, so this is going to stay like it is, and this will stay like it is. The only thing we can do is we can add some other zeros to it, because I can't tell how do I get to a 2. I'm going to put some zeros here in order for me to be able to borrow from the 7 to get the proper solution over here. So to make this work, I'm going to borrow from the 7 and make that a 6, and then regroup that to be a 10. And borrow from the 10, make it a 9, and make that a 10. So now I think to myself, 10 minus what number gets you to 2? 10 minus 8. 9 minus what becomes 1? Okay, 9 minus 8 is 1. Over here, 6 minus what gets you to 0? 6 minus 6 becomes 0. And 0 minus what becomes 0? 0 minus 0. Keep our decimal there. So we'd say 0.688 for that one. The next one, same idea. Let's go ahead and add our placeholders. Add the zeros there. Okay. And so we would borrow all the way around. We make that a 6. That becomes a 10, becomes a 9, becomes a 10, becomes a 9, becomes a 10, becomes a 9, becomes a 10. And then we could think about subtraction, or here's another way. 7 plus what is 10? 7 plus 3 is 10. 6 plus what is 9? 6 plus 3 is 9. 5 plus what is 4? 9, sorry, 4. And then 4 plus what is 9? We'd say 5. And then 3 plus what is 6? We would say 3. So if you like doing addition, and once you've done that part, you could add to go that direction, and it works just the same. Here's another one. We're going to put our placeholders here. Put our decimal point there. And let's see here. We're going to borrow from the 7. And that becomes a 10 there. And borrow. 10 there. Borrow from that. Make it that. Borrow from that. There. Borrow from there to make it there. And 10. So you can do either way. We could subtract, or say what's missing, or add up. Either way. So 9 plus 1 is 10. 8 plus 1 is 9. 0 plus 9 is 9, 0 plus 9 is 9, 0 plus 9 is 9, and then 0 plus 0, in this case here, this is a 0 right here, nothing there, 0 plus 6 is 6. Alright, so that one's a little funky right there. Just take a look at that. It had to add an extra 0 there. So we added zeros to the back of that number and to the front of that number to make that work. But that's okay. No problem at all. Okay, so just in summary today, it says that base 10 diagrams work best for representing subtraction of numbers with few non-zero digits, such as 0.16 minus 0.09, or 16 hundredths minus 9 hundredths. For numbers with many non-zero digits, such as 0.25103 minus 0.04671, it would take a long time to draw the base 10 diagram. With vertical calculations, we can find this difference efficiently. So yes, you can make visual representations. You could use your blocks and your sticks and whatever. We could do that again and again and rebundle and regroup, but it's just a lot more efficient to just do it vertically with vertical representations like this. Okay, and we can just do the unbundling or decompose things to make it work the way we want it to work there. All right. Take a moment here and pause, and then work on your homework, and we'll come back and check it together in just a minute. Okay, here we go. Homework for Math 6, Unit 5, Lesson 4. For each practice subtraction problem, circle the correct calculation. So 7.2 minus 3.67, we're looking for how we align our decimals. When I look here, one thing I noticed with this first one As I notice that, the decimal points go like so. They go whoop, whoop. That's not going to quite work. This one goes like that. That's not going to work. And that one's lined up. So to me, that's going to be the best one to use for A. The best way to do those there. The next one here, there's actually a decimal point here behind the 16. So we're like this. This one's like this. And this one is lined up. So again, we would say this is the best way to do the subtraction problem, by lining up your decimals and doing the subtraction. Okay, explain how you could find the difference of 1 and 0.1978. Now this is an explain, not just do it. I'll show you how to do it real quick, but you want to be able to explain how would you set this up. It's important to know that you'd set up by saying that 1 as a whole number would be like this, but I would need to, when I subtract the 0.1978, I would need to add some placeholder zeros, some non-zeros, in order to make sure I could demonstrate how that calculation could be solved. Okay, so I'd have to add those zeros there to do that, and then I would borrow from the 1 and regroup or unbundle it so that I could then unbundle this one, unbundle this one, unbundle this one, and unbundle here, so that we can then do the subtraction. Without the unbundling part, it's hard to do that. 10 minus 8 is 2, 9 minus 7 is 2, 9 minus 9 is 0, 9 minus 1 is 8, and then we have a 0 there. So 0.8022. Okay, so again, the words you want to do is some regrouping or unbundling or decomposing, decompressing, composing, those all work good. Number 3. A big bag of chocolates is labeled to contain 0.384 pounds of chocolates. The actual weight is 0.3798 pounds. Are the chocolates heavier or lighter than the weight stated in the label? Okay, so we have two things. We have the actual amount, which is 0.3798, and we have the labeled amount, which is 0.384. So to decide if it's heavier or lighter, we need to compare those two things. So the label here is 38, this is 37, so this is going to be the greater one, which means the actual is less than the label. So since the actual is less than the labeled amount, we would say the actual is actually lighter, because it's wanting to know this one. Is this heavier or lighter than that? It's lighter because it's less. So the question then is, how much heavier? Well, then we have to compare. So we'll take the larger number, 0.384, and subtract 0.3798. Notice here that I need to add a spaceholder 0, a non-zero right there to make that work. Okay, so we're going to go ahead and borrow from here, unbundle. So 10 minus 8 is 2, but now I have 3 minus 9. Can't do that. So to unbundle that 8, make it a 7, to make that a 13. 13 minus 9 is 4, 7 minus 7 is 0, 3 minus 3 is 0, decimal point, and there. So how much of a difference is there? Well, this is our tenths, hundredths, thousandths, and our 10,000ths. So we could say that it is 42 thousandths, or 42 10,000ths. Is the difference. 42 10,000ths. Kind of weird number. We could say 4.2 thousandths as well, if you want to say those. The saying of things is always a little bit tricky sometimes. Alright, number 4. Complete the calculations to show the correct sum. So we're going to go ahead and do this. Take a look here. Calculations. So we have those blocks again, or spaces, like we did in our lesson today. So we want to make sure this ends up being 4.000, 1.000, 1.000. So we're adding. That's great. So 6 plus what can give you 10? 6 plus 4 is 10. And again, I'm looking for 10, so I can have a 0 right there. 1 plus 3 is 4, and 4 plus 6 is 10. There's my 0. 1 plus 0 is 0, plus 9 more is another 10. And now I'm sitting at a 1 and 1 is 2. I want to get to 4, so let's add another 2 there. So 2 plus 2 is 4, and I have 2.964. Again, adding here on B. So 8 plus 2 is 10. 1 plus 3 is 4, plus 6 is 10. 7 and 1 is 8. 8 plus 2 is 10. And 1 plus 0 plus 0 is 1. And C, 7 plus 3 is 10. 1 plus 3 is 4. 4 plus 6 is 10. 1 plus 1 is 2. 2 plus 8 is 10. 1 plus 5 is 6. 6 plus 4 is 10. And 1 plus 0 plus 0 is 1. And there we go. That's how we do those ones there. Number 5. 5 is a great little question. A shipping company is loading cube-shaped crates into a larger cube-shaped container. The smaller cubes have a side length of 2.5 feet. The larger shipping container has a side length of 10 feet. How many crates fit in the shipping container? Okay, so let's just remember back to, we did a problem like this before, where we had, remember we had a cube like this. And if we said the cube was going to be, let's say it was, if each cube was 2, okay, if each cube was 2 inches long, alright, and I want to know how many 1-inch cubes could I put in there. Well, that's like dividing this into those parts, right? I can get 2 on that side, like this, like this, like this. And so if these were 1 inches, how many of the 1 inches are inside of the 2 inch? Okay, well, in this cube here, we know that we have 4 on the bottom, 1, 2, 3, 4, and 4 on top. So we actually get 8 of the small ones inside of one of the large cubes. Okay, and that's because when you do a cube, what you're doing is you're doing a side length. Okay, we're taking a side length and we're multiplying it by itself. So 2 times, or we're doing, we're doing it cubed. So it's going to be a cubed value because it's cubed. So it's the third power. Okay, so here, let's take a look. This is going to be 2.5 feet is our first one. And the container happens to be 10 feet. Would you agree? So how many 2.5s can we get in 10? Well, 2.5 plus 2.5 is 5. So that's half of 10. And so we get another 2.5 and another 2.5 there. Right? We good with that? So we actually, it's 4 times larger, isn't it? In terms of the length, it's 4 times larger. But that means the width is times 4, the length is times 4, and the height is times 4. Because this one here, this one was, in this case here, we just did it times 2 because we doubled it. Now I'm going to make it times 4. So whatever that 4 is, okay, I'm doing it 3 times. 1, 2, 3. So in this case here, we do 4 to the third power will tell us how many of these would fit inside of there. I'm going to cube the 4 because I'm making a bigger cube, and 4 cubed is going to be 4 times 4 is 16, and 16 times 4 is 64. Okay, so because I'm cubing it, that tells me what it's going to be. See over here, I had 1 of them, okay, and because I doubled it, I did 2 cubed, and then 2 cubed is 8. So I got 8 small ones inside of 1 big one. And that's how that works. Here I'm times 4, so I'm going to, the length, but also the length and the width and the height, so it's cubing the 4. Alright, the last one here. It says for every 9 customers, the chef prepares 2 loaves of bread. Here's a double number line showing varying numbers of customers and loaves prepared. So when there's 9, there's 2. If this goes up to 4, we're doubling that, so this becomes 18 right here. Okay, we can see we have 9, 18, 27. So this is going to be, in this case, this is times 2, this is times 3. So 2 times 3 is going to be 6. Anyway, so let's see what's on the next page. It says complete the missing information, which we did there. That's great. We can continue adding one more. We could do 9 times 4 is 36, and 2 times 4, which would be 8. So that would work there. So we have 18, 27, 36, or 2, 4, 6, 8. That's complete information there. We can put the same information, of course, in a table. Okay, So again, this is 9 times, or good to go, not 2 to 4 is times 2. So 9 times 2 is 18. To go from 9 to 27 is times 3. So 2 times 3 is 6. Okay. To go from 2 to 14, 2 to 14 is what? It's times 7. So let's do 9 times 7, which is 63. And to go from 9 to 1, that would be multiplying by 1/9. Because 9 times 1/9 is 1. So to go from 2 to that one is times 1/9. So 2 times 1/9 is 2/9. That's our table there. Again, whatever we do to the left side, we do the right side. We multiply by the same way. So how many loaves are needed for 63 customers? Well, that's right here. We would say 14. How many customers are there if the chef prepares 20 loaves? Okay, so we can make another row here if we wanted to and say if there's 20 loaves, then how many customers? Well, to go from 2 to 20 is doing what? Times 10. So what is 9 times 10? 9 times 10 is going to be 90. So we would say that there would be 90 customers if he made 20 loaves. How much of a loaf is prepared for each customer? The each customer means one customer. Okay, so how much is prepared for one customer? It's right there. When there's one customer, there's 2/9 of a loaf is prepared for one customer. All right, that's it for today. Have a great day, and we'll see you next time.